Okay, so continuing with example 7, thought we were going to have an interruption. So far what I've done is I took the integral inside, and now I have to take the derivative. So remember, to take the derivative, maybe we'll just take one extra step, just because sometimes kids have trouble going back and forth from integration to derivatives. So maybe I'll write this as 1/3 x to the third plus 3 over 2 x squared minus 5x plus c, just to help out with the derivative. So again, with the derivative, we have our constant 1/3. We drop our 3, and we make it x squared, right? Don't forget derivatives. We've done that for a long time. We have 3 over 2 times our 2x minus 5. And what's the derivative of a constant? 0. Okay, so then we just go through and clean this up a bit. We end up getting here x squared plus 3x minus 5. And if we take a second and look, the derivative and the integral have undone each other, leaving our integrand x squared plus 3x minus 5. And therefore, what 8 is summarizing is finally, instead of just saying that these are opposites, we can say, hey, look, these are what? These are inverses. Okay? So if you want to put something here, you could put something like integrals and derivatives are inverses. I'm hoping you were thinking all along. Okay? All right, we are just about finished. We have one major topic left in these notes. Okay, these are kind of cool problems. Connecting the concepts of integration and differentiation. Okay, so let's take a moment and read this to yourself. Okay, so let's focus right here. The tangent line has a slope of x squared. The slope of the tangent line, what is that? Okay, I'm hoping you're saying derivative. So this is the derivative. So let's write dy dx equals x squared. Okay, and they want us to find an equation. So find an equation for the curve that this particle is traveling along. So we're kind of working backwards. We don't know the original equation. We know the derivative of that. And it says that it's also going to pass through this point 2, 1, which we'll be able to sub in at the end. Okay, so this is our first example of a differential. So differential equation. Okay, and if you look right below this differential equation number 10, it says differential equations is an equation that involves a derivative of an unknown function. So we have a derivative of an unknown function. This is different than the equations you've been working with, because at this point the unknown is no longer a number, it's a function. Okay, so that's where we're starting, and the rest of our notes we'll deal with this. Okay, so here we go. We're going to start by writing dy dx, what we do know, equals x squared. And to figure out what our function originally was, we are going to multiply both sides by dx. So dy, the derivative of y with respect to x, we can multiply and get dy equals x squared dx. Okay? Since we just learned that we have inverses, a derivative and an integral are inverses, why not say, I don't want the derivative of y, I just want y. And if I just want y, can I integrate to get rid of the derivative? Okay? And so if I integrate, of course, both sides, I'll end up getting y alone. I'll get the function or the equation that I am looking for. So let's go through and take this simple integral. We have x to the third over 3 plus c. Okay? Now what's cool about this is they're basically there. We have our original function, right? But we have this plus c, and it's not okay. Sorry, I'm really sorry. I just got a low battery notice on my iPad, so that's why we paused that random pause there. Hold on one second. I think we're good. Okay, so what I'm saying is, just to finish this example, the C here is, it needs to be solved for. So what are we going to do? How are we going to figure that out? Well, here it is right there. We have the ordered pair 2, 1. So this is your X, and this is your Y. So you simply sub that in. So here's my Y is 1. X is 2, so 2 to the third is going to get me 8 thirds plus C. And you can see now, I can go through and solve for my letter C. So what is 3 thirds, right, minus 8 thirds? And we should all get negative 5 thirds, right? So negative 5 thirds is my C. And now that I know what my C is, I go back to my function and I say, hey, now I know the whole thing. Y equals x to the third over 3 minus 5 thirds. That is the original equation that my particle is traveling along. Okay? So I already read number 10 to you, so go ahead and just skip that. Go to our last page. Okay, so this is number 12 for you guys on your notes. Solve the initial value problem with the given initial conditions. This is just another type of differential equation, so you can write that next to it. The initial value problem means they'll be giving us some initial value, but we'll still be looking for the original function. Okay, so here we go. We have the derivative equals the cosine. So once again, we're going to say dy equals the cosine of x dx. We want to get rid of the derivative of y and just have it say y. So we're going to take the integral of both sides. That gets me y. Okay? The integral of cosine is what? We should have the sine plus that constant. Once you get that far, you're just about there, but you do have to sub in your initial condition. So when your input is 0, your output is 1. So this is your x and this is your y. So my input is 0, so the sine of 0 plus c. My answer is 1. Okay, now I go through and I draw my little chart. The sine of 0, well 0 is here. And you can see that that is 0. So 1 is equal to 0 plus c. 1 is equal to c. Again, final answer, you go back to your function. Y equals the sine of x and add a 1. So right here, y equals the sine of x plus 1. Okay, and we have 2 left. Okay, first thing I'm going to do is rewrite this as 1 over 8x to the third, right? Remember to cube everything. There's your initial value problem again, and here we go again. Looking at this problem, again, I'm going to multiply both sides by dx, and then I'll have to integrate. So let's see, let's do dy equals 1 over 8. I'm going to write that as x to the negative third, so I have my eighth as a constant, my x to the negative 1/3, and then that's my dx. I've not taken any integrals, I just rewrote this function a little differently. Now I'm going to take my integral, so I get y alone. The 1/8 can be pulled through. There's my x. I add 1 and get a -2 and divide by it, and I add my c. Okay, so then just to fix that up, I'm looking at y, let me write it here, y equals negative 1 over 16. X squared goes to the denominator, and then we have our plus c. Okay, so again, we're just about there at that point. We have our function, but we do need to solve for c using the initial condition. This is your input, this is your output. Input is x, output is y. So we have, oops, we'll make that a 0, right? 0 equals negative 1 over 16. Our x is 1, so 1 squared, essentially. We're looking at 0 equals negative 1/16 plus c. So 1/16 is equal to our c. And then finally, once you have that, we go back to our problem and just sub that in. So y equals negative 1/16, oopsies, put that x squared in the denominator, x squared plus a 16th for your final answer. Okay, they're very repetitive. I think the first one might have been hard. You might not have known how to handle it, but once you see what to do, you're good to go because you just follow the same steps. Okay, last example for you guys, that would be number 14, and we will be finished this lesson. Okay. Now with this one, if I multiply both sides by dx, as we've been doing, what you see here is I'll get a dx over here, but there's y's with it, and that's not okay. So what we have to do whenever you have a problem, a little bit harder in the fact that you have x's and y's, you need all your x's on one side and all your y's on the other side. So that's how I'm going to start with, or that's what I'm going to do to start. So for this one, I'm going to take basically the cross products, right? So I'm going to take that 2y plus the cosine of y dy, so that's this diagonal, I multiply that, and that's this, equals 6x squared dx. Okay, so that worked out nicely because, again, I have my y's here and my x's here. Okay, once I have that, now I'm going to say, all right, well, this is the derivative of y, and I don't want the derivative of y. So as before, I'm going to integrate. I'm going to integrate the left side and the right side. So we have 2y squared over 2 plus, what is the integral of cosine? Hopefully you're saying sine. Okay, and now this is the tricky part. Normally when we take an integral, we put plus c. So I'm going to do that right now. I'm going to put plus c sub 1. Okay, and we're going to talk about that because that's actually not necessary. And then over here, we'll take this integral, so 6x to the third over 3, plus, again, we'll call that c2, because that's a different constant. Okay, so to clean this up, just because we have some reducing to do here, I have y squared plus the sine of y plus c1 equals 2x to the third plus c2. Okay, now, why do I not really need to put this c1 here? Well, because in the end, if you have, say, a 3 here, and a 5 there, aren't you going to combine them to make a whole different constant? So you actually don't really need to put the constant with the y. Just make sure you have a constant with the x, and that will compensate for all of it, because that would combine with that anyway, if that makes sense to you. If you want to write it, it's not going to hurt you, because in the next line, when I go through, I could just say, well, if I want to subtract c sub 1, c sub 2 minus c sub 1 could be c sub 3, and now it's all in one spot. See what I mean by that? Let me write that down even. Okay, let me subtract c sub 1. Okay, now I have some different constant. I don't know what those numbers are, but they're constants, so they can be combined to be some other number. The plus, it makes no difference because that could be a negative or a positive, it's just a constant. So if you want, right from the whole beginning, don't put a c here, just put a c there, and you'll have it in the first place, okay? So that's where we are with that. Once we get to this point, we have to go through and use our initial condition. So this is your x, and this is your y, okay? So let's start to sub that in. So y is actually pi, so pi squared, plus the sine of pi equals 2. X is 1, so that's just going to stay 2, plus our c, okay, which you can just call it c at this point. Okay, the sine of pi, if I were to just quick draw that, pi is over here, and so we have the order pair negative 1, 0. So the sine of pi is 0, so we're looking at pi squared, subtract that 2, equals c. So my constant is pi squared minus 2, so then I go back to the original problem, and we can just say, we'll just go like, let's go here, where my constants have been all combined together, and our final answer will be y squared plus the sine of y equals 2x to the third, and then we'll do a plus pi squared minus 2. Okay, and then we'll leave it like this. In this problem, due to the fact that we have a squared and a single y in here, we cannot solve this just for y, so it's just going to be ugly in the end. Okay, well that's it, guys. That's lesson 6.2. Hopefully you don't feel like basic integration's too bad, and then we have a bunch of practice worksheets and homework for you to start to get a better handle on it. So, all right, see you guys later. Bye.